There has a peptide that has been gaining significant attention in the world of skincare, longevity, and regenerative medicine. It's called GHK-Cu. You may see claims that it can reverse aging, repair skin, stimulate hair growth, reduce inflammation, and even influence thousands of genes involved in skin repair. But how much of that is actually supported by scientific research? In this video, we're going to break down what GHK-Cu is, its discovery, mechanisms of action, pharmacology, and studies that have investigated its biological effects. So, what is GHK-Cu? GHK-Cu stands for glycyl-histidyl-lysine copper complex. It's a naturally occurring tripeptide composed of 3 amino acids, glycine, histidine, and lysine. When this peptide binds to copper ions, which is the Cu component of GHK, it forms the biologically active compound GHK-Cu. This molecule is naturally occurring within the body in human plasma, saliva, and urine, and concentrations decline as we age. This observation led researchers to speculate whether or not GHK-Cu may play a role in the body's natural repair and regenerative systems. So, how was it discovered? So GHK was first identified in the early 1970s by a biochemist, Lauren Pickart, and in early experiments, Pickart discovered that this small peptide could restore normal growth patterns in damaged liver cell cultures. This observation suggested that this simple 3 amino acid complex could influence complex biological repair mechanisms. And over the following decades, researchers began investigating GHK-Cu in wound healing, skin biology, inflammation, and tissue regeneration, with studies showing that GHK-Cu might appear to influence tissue repair, modulate fibroblast activity, which is important for collagen synthesis and wound healing, modulate reactive oxygen species, which also reduces inflammation, and then potentially act as a regenerative signaling molecule. So today, GHK-Cu is primarily used in topical dermatologic formulas and cosmetic formulations. It appears in many anti-aging skin products, experimental wound healing treatments, and hair biology research. It's important to note that GHK-Cu is not currently a FDA-approved systemic therapeutic drug, so most commercial applications today focus on topical delivery where the peptide may influence skin repair processes. So what are the potential biological benefits of GHK-Cu? Well, studies suggest it may stimulate collagen synthesis and extracellular matrix remodeling, processes that are essential for healthy skin structure. It may also exhibit anti-inflammatory properties and reduce oxidative stress. Additionally, there is some research to suggest potential effects on hair follicle biology, although clinical evidence for hair growth benefits remains limited. And it's important to note that we do have certain mechanisms or certain drugs already out there, like topical minoxidil and finasteride, that have been shown to be useful. But currently, we haven't really found a way to reverse hair loss. We've just found ways to prevent it from occurring further. So as far as hair loss goes, topical minoxidil and finasteride are still going to be your go-tos. Now for mechanism of action, GHK-Cu appears to function as a signaling molecule rather than a traditional receptor binding drug. One of its most important roles is copper binding. Copper is required for many enzymes involved in tissue repair and antioxidant defense. GHK-Cu may act as a delivery system that transports copper ions to tissues that require them for repair. The peptide also stimulates fibroblast activity. Fibroblasts are responsible for producing collagen and other structural proteins in the extracellular matrix. There are also gene expression effects. Another interesting feature of GHK-Cu is its influence on gene expression. Some analyses suggest that this peptide may influence genes associated with tissue repair, inflammation, and antioxidant defense systems. While these findings are intriguing, most of the evidence comes from a laboratory study rather than large clinical trials, so we need to take this with a grain of salt. The pharmacokinetics of GHK-Cu in humans are still not well characterized. Available literature suggests that this peptide has a relatively short half-life in circulation, potentially on the order of 30 to 60 minutes. Because this molecule is so hydrophilic, it does not easily cross the lipid barrier of the skin. And as a result, researchers have explored different delivery strategies, including liposomes, hydrogels, and microneedling systems to improve tissue penetration. Multiple laboratory studies have shown that GHK-Cu can stimulate fibroblast growth and collagen synthesis. It also shows reduced TGF-beta signaling in scar molecules, as well as increased VEGF and repair growth factors. VEGF stands for vascular endothelial growth factor, and essentially is a molecule that increases the amount of blood vessels that will grow within a certain area. It's a angiogenesis promoting molecule. So the more VEGF you have, the increased blood flow that you should theoretically have to a certain area. In addition, there are some antioxidant studies that have also shown reductions in reactive oxygen species in cell models exposed to oxidative stress. So this can be very useful in the context of sun damage, where you have a lot of ionizing radiation that is causing inflammation at the level of the skin. So you can use this as a way to prevent increased damage, as well as build back some collagen that was damaged through the ionizing radiation in the sun. So if you are somebody who gets a lot of regular sun exposure, as I am, this peptide looks like a great way that you could prevent some of the damage that's occurring to your skin. Now, despite some promising mechanistic research, there are several limitations in the evidence surrounding GHK-Cu. Many studies are preclinical and they involve cell cultures or animal models. Large randomized human clinical trials are very limited, and delivery challenges also complicate interpretation of the results, as effective penetration into tissues may depend heavily on the formulation and delivery method. So it's going to be very important to look at the mechanism by which the GHK-Cu is being delivered. If you're just buying raw GHK-Cu cream for whatever reason from some random company from China, none of that's getting into your body. There needs to be some kind of liposomal preparation or some kind of mechanism by which the GHK should be absorbed. So make sure to be very careful about that. There are also some systemic preparations that you could possibly take. Like you could do a subcutaneous injection in your belly. There's also just oral formulations. All of these could be potentially useful, but I do think there are some good topical agents that you could use just on your face and neck. I'm myself going to be doing a 30-day trial with GHK and then telling you guys what my findings, what the results are, how I feel about it personally. Do I think there's any difference to my skin from 0 days of using it to 30? So in conclusion, GHK is a fascinating peptide with decades of research suggesting roles in tissue repair, collagen synthesis, and modulation of inflammation and antioxidant stress. However, while mechanistic evidence is strong, clinical evidence in humans remains limited. For now, most evidence-supported uses appear to be in topical dermatologic applications. Future research may clarify whether GHK-Cu can play a broader role in regenerative medicine. So that's going to be it for today's video. I hope you guys enjoyed. Please like, comment, and subscribe. It really helps out with the algorithm. And with that, we'll see you in the next video.